start this thing? All right, so actually, just so you know, you guys can see that, right? Record all my lectures if my computer works. Sometimes it crashes, the program that records it, but otherwise, if it doesn't record, if it works and doesn't crash, everything that I say is going to be posted on YouTube, right? So you only see the screen, you don't see me. Obviously, there's no camera here. Whatever you see on the screen gets recorded and uploaded to YouTube, right? Unless it crashes, which happens every once in a while, but it doesn't happen that often. Yeah.
How about your voice?
Yeah, you hear what I'm saying.
Okay.
Yeah. Audio and the screen gets recorded, but I don't get recorded. I'll explain how it all works when I go through the syllabus. So let me just go through the syllabus, right? When I go through the syllabus, I'll explain how it works. Okay, so first of all, this is General Physics 1, right? Everyone's in the right class, right? Hopefully. All right, so we meet, obviously, every day except Friday from 1 to 3:10. I'll give you a break around 2 o'clock, though, right? I'll give you a 10-minute break because 2 hours and 10 minutes straight through is a little bit much for both me and you. So around 2, plus or minus 5 minutes, I'll give you a 10-minute break, right? Then you come back and we finish the class. So we always meet in this room, all the tests are in this room, everything's in this room as far as the class goes. My name's Dr. Gross, and my office is in the Science and Engineering, well, actually it's a science building. It used to be the Science and Engineering building, but they changed it to the science building. But anyhow, it's SC 118, which does everyone know where the science building is?
Yeah.
Okay. So I'm on the first floor, down the hall from the physics office, which is SC 108. So for labs, you probably sometimes would want to drop off labs to your TA, and the mailboxes for both the TAs and myself are in the physics office, which is in SC 108, right? But I don't think you need to put anything in my mailbox, because it almost never happens. I don't have a phone, but my email is rgross100@fau.edu, or you can use Canvas. Canvas also allows you to send emails as well. All right, so my office hours are, by the way, this syllabus is going to be posted on Canvas. Canvas is the learning management system where everything will be posted, all the notes and everything associated with the class, right? Including the syllabus. But anyhow, my office hours are Monday from 11:30 to 12:30 in the morning, obviously. Tuesday 11 to 12, and Wednesday 3:30 to 4:30. So 2 times before the class, 1 time after the class. And if you can't make it any of those days, you can email me and try to set up something outside of those times. Otherwise, I'll always be in my office at those times. You can come by whenever. You don't have to make an appointment, right, if you want to stop by. We have an SI. For those of you, I know some of you are just taking a class here in the summer. So SI is supplemental instruction provided by the university. They're basically sort of tutors provided by the university itself. And we have an SI. I think he's going to introduce himself tomorrow. He emailed me. But anyhow, he has sessions as well, which are basically sort of tutoring sessions, which are Tuesday and Wednesday from 4 to 4:50 p.m. in GS 222, right? So it's this building, right, on the 2nd floor, right? And I also do a review session. It's going to be Mondays at 4 p.m. in SC 319A. So it's the same building as where my office is. It's on the 3rd floor, right, of that building. 319 is 3rd floor. So for the review session, as you'll see in a minute, the tests are basically going to be on Tuesdays. There's a reason for that, but I'm not going to go into it. But anyway, the tests are on Tuesdays, right? So the review session is on Monday, the day before the test. So basically, a review session, we can just, you can just ask me questions, regarding the test or whatever questions you have, right? And we can go over things. And that's what the review session is for. So it's not today, though. It doesn't start today. It starts next week, right? Monday starting next week. And there's also, I have some TAs as well, and they're going to provide tutoring as well. Except they're figuring out their schedule today and tomorrow. I should know it by the end of tomorrow, what their schedule is. And when I know it, I'm going to send out an announcement or an email using Canvas. I'm also going to, I have this schedule where you can see everything, like, just in one sheet. It's like a calendar. You can see all the office hours and the SI hours and all the tutoring hours when everything's finalized, which would be probably by the end of the day tomorrow. So yeah, I use Canvas. Everything is going to be on Canvas, so you have to make sure that you're on Canvas. Said Blackboard. I meant to change that to Canvas. Anyhow, that'll be changed to Canvas, right? We used to use Blackboard, but we abandoned it last semester in lieu of Canvas. So I might have Blackboard in this syllabus, but I meant Canvas. Anyhow, so make sure you're on Canvas, right? So when you enroll in the course, you should automatically be enrolled in Canvas, right? Does everyone know what I'm talking about, what Canvas is, right? Okay, so there should be a general physics thing there, and you log in, and it should be fairly intuitive how to find everything. It's not that hard. But make sure you see it, right, tonight. Otherwise, I have to enroll you manually. All right, so the book, there is no book, right? So basically, I use this computer for the book. You'll see how it goes. Basically, there's notes and examples. And I make a PDF of all the notes, along with the video, right? So the video I post on YouTube. But along with the video, there's a PDF of everything that I write, right? Everything that we do is printed and sent to Canvas, right? So that's the book. There is no book. If you want, some people don't like the fact that there's no book, you can get any used physics book, right? So the new books are too expensive. That's the number one reason why I don't use a book. So you can get, the physics that we've done, we're doing, hasn't changed in 200 years or 250 years. So you can buy any used textbook, and you can get supplementary material from a used textbook, or this thing here, this Shams outline. It's also good. Shams outlines are pretty good in general. They basically just have a bunch of solid physics problems in it, right? And it's cheap. That book is like maybe $20 on Amazon or something new, right? So if you want any additional books, just get a used physics book or this thing, or just use the internet. There's a bunch of stuff on the internet as well. Just Google physics problems, right? It's all the same, basically. All right, so there's no book. And it's a prerequisite. So a lot of this stuff we need in here just to get accredited for the syllabus, and it needs to be a certain format. But anyhow, so this general physics course is a basic sort of general physics course. Basically, any where you go, any university you go. First semester general physics is basically the same thing, maybe covered in different orders, but basically the same thing. We first go over kinematics, so you don't know any of these things, maybe now if you haven't taken physics before, but you will know it soon. So kinematics, basically how things move, what velocity and acceleration is, and then we talk about Newton's laws of motion, and then we go on to concepts of work, energy, momentum, torque, rotational motion, all this stuff. You'll learn it as we go, right? But basically what I'm trying to say, it's it's typical general physics course, general physics 1 course. So if you have a disability, either a learning disability, some other disability, you can contact the, what do they call it now? They just changed the name of this a little while ago. Student Accessibility Services. There's, on this campus, so it's SU 133, if you need to set that up to take the test at some other time. And anyhow, so let's go on to this. So basically there's only, because it's a compressed semester, normally I give homeworks and things like that, but it's too much to do. There's too many things going on if I give you graded homeworks and quizzes and tests every single week. So every week I basically will give you a quiz, and starting next week a test. So let me just go over the weighting first, and then I'll tell you how the quizzes and the tests work. So the quizzes are either 20 or 30% of your grade, depending on what your quiz average is, and your test is either 70 or 80% of your grade, depending on what your test average is. So basically, if your quiz average is greater than your test average, then your quizzes count for more, so they count for 30%, and your tests count for 70%. If it's the other way around, if your test average is better than your quiz average, then the tests count more, and your tests are 80%, and your quizzes are 20%. So that's individual per student, not for the whole class. It's not the class average, right? It's the individual average. So that's basically how it works. So let me go on here. Your lowest quiz grade will be dropped. I'm not dropping test though, right? So all your tests count. However, for the quizzes and tests, it's, as you'll see, because I'll talk about it later on in the syllabus, The points are more than 100, so you can get more than 100 on the quizzes, and you can get more than 100 on the test if you get everything right. And those are just extra points that you can sort of use for other tests. I mean, you can just build up the extra points over the course of the semester, right? Is what I'm trying to say. So basically how it works is for the tests, every Tuesday after after tomorrow, there's no test this week, because we can't have a test this week, right? But every week after this week, there's going to be a test basically on Tuesday, right? So the first test is next Tuesday, and then it keeps on going from there, right? And there is no final. The test is the final, right? So I'll explain how that works when we get closer to it. But for now, just worry about, test 1 and test 2, whatever. And test 1 is going to be next Tuesday. Like I said, we have a review session on Monday, so that's why the review sessions are on Monday. And we're also going to review during class on Monday a little bit. Not the entire class, but a portion of the class, right, on Monday. Now, how the quizzes, so makeups, you can read all this on your own. Makeup, it's standard policy. You need to have a legitimate excuse with documentation to take a makeup, but if you have the documentation and a legitimate excuse, then you can be given makeup, right? All right. So sessions, tutoring. Let me skip to the quizzes, and then I'll come back to the attendance and everything, and homeworks. All right, so quizzes will be given on Canvas. They'll be posted, I think, sometime on Friday. I'm not quite sure what time. Hopefully fairly early in the afternoon on Friday. So it'll be posted on Canvas. I'll give you instructions on how to do it when I first post the first quiz. And then all the rest of the quizzes are the same thing. So once you figure it out once, you've got it figured out. But I'll post instructions when I post the first quiz, right? So it'll be posted on sometime on Friday, and you'll have basically the weekend to do it. It's how it works because it's a compressed semester. So basically Saturday and Sunday, and then it'll be due sometime on Monday, right? But you shouldn't really wait too late on Monday to do it because you only get one shot at the quiz, and if something happens, like your computer turns off or you lose power or something, then it's going to give you a 0 on the quiz, which you don't want, right? But if that happens, you can email me, and then I can reset the quiz so you can do it again, right? But if you wait too late, then there might not be, I might not have time to reset it and for you to retake it, right? So you can't wait a long time, right? So in other words, if it's due Monday, you should take it on Saturday or Sunday just in case something like that happens, right? Because if you wait too late and I can't reset it, it's going to be 0. Does everyone get that? Okay, so the quizzes will be 10 questions. They'll be timed. It's sort of like a mini test. You should approach it as a mini test because the quiz material will be on the test, right? So the things that are on the quiz will be on the test, right? So if you do well on the quiz, you probably do well on the test. If you don't do well on the quiz, then it tells you what you need to study so that you can improve for the test, right? That's what they're supposed to be for. So the first quiz will be on this week's material, right? Right? So then at the end of this week, I'll give you a quiz that's on what we did this week. And then next Tuesday, I'll test you on what we did this week. And I'll just keep on going like that. Next week, there'll be a quiz will be what we do next week. And the test after that will be on what we do the second week, right? And that's just how it'll go the whole semester. So the quiz will be 10 questions. It'll be timed. I'm not going to give you the answers for the quiz when you submit it. But after the quiz is due, I'm going to post the solution of the quiz in its entirety. So I'll post the notes, step-by-step solution on how to do the quiz problems. And I'm also going to give you a video explaining how you do each step, because sometimes you can't follow the notes by itself. You need an explanation of how it goes. And that'll be posted a few minutes after the quiz is due on Monday, right? So the quiz will be due, say, noon on Monday. And then a few minutes after it's due, the quiz solution will be posted, right? So you can see immediately what you did wrong and how to correct it. Yeah.
Posted on YouTube, right?
Yeah, so the quiz solution video will be posted on YouTube, and the PDF notes will be posted on Canvas. Yeah. So the other thing you can do is, the other thing you should do is also make a PDF printout of your quiz result after you take it, or print it out, just in case Canvas doesn't record what you do. That happens every once in a while. It doesn't happen that often. So when you submit the quiz and you see your grade, just either save it to your computer as a PDF or print it out, right, so you have a record of it. All right, so does everyone understand how quizzes work? So there's basically 5 quizzes, and one of them gets dropped, right? The lowest one gets dropped, right? So the highest 4 count. right? All right, so then homework assignments, I'm not going to give you graded homework assignments, but, oh, sorry, yeah.
Do you recycle quiz and homework questions for exams?
No. Well, homework might be slightly recycled because they're not graded, but quizzes will not be recycled, and test questions are not recycled. So I was getting to the homework. So the homework isn't going to be graded, but almost every day, I'll try to do this. Sometimes I don't have enough time. But I'll try to do it almost after every class. I'll try to give you a couple homework problems to work on, right? And I'm not going to grade them, so it's up to you to work on them, right? But I'll give you the answer maybe the next day, and I'll also give you a solution on how to do it at the end of the week, right? At the end of the week, after I posted a few problems, I'm going to do a homework solution too, right? So you see how to do the homework problems. So, but the homework isn't graded, right? It's up to you to try to figure it out. But it helps. If you can do the homework, then you're more likely to do better on the test, right? All right, so does everyone understand that? Homework, quizzes, and the tests. All right, so the test, let me just do one more thing about the test. The test will be multiple choice. There'll be about 20 questions, give or take, 5 or so. It depends on how much material we do. But it'll be more than 100 points. And the quiz will be more than 100 points as well, right? So if you get a perfect score, if you get no questions wrong on the test or the quiz, you get more than 100 points, and that's extra credit that you can use towards your grade. You can just build up the extra credit. So I provide an answer key, so you don't need to get a Scantron. The only thing I ask is that you bring a pen, because you need to use a pen to answer your multiple choice, you know, to X out the answers on your answer sheet, and you need to bring your ID, right, for the test. And the test will be an hour and a half. They're not going to be the entire class. I'm going to lecture for because the semester's compressed, so we need as much time as possible to lecture. So the test will be an hour and a half, and then you can take a little break, and then you'll come back and I'll lecture for like 20 minutes to half an hour, right, after the test on Tuesday, right? But an hour and a half is plenty of time for like 20 or so questions. It doesn't take that long. Most people should be done in like an hour if you've studied, right? If you haven't studied, then it might take a while, but that's the whole point of studying, right? Anyway, so that's how the tests work. All right, so don't cheat, and you shouldn't work on quizzes together. Quizzes are supposed to be individual. You're supposed to do them by yourself, not with other people. All right, what did I skip? Okay, here, attendance. Yeah, so my attendance policy is that I don't have one because you know, I think attendance policies are kind of dumb in college anyhow. But yeah, I actually prefer that if you're not going to pay attention to not actually come, right? Because it's distracting. I don't know if anyone of you tried teaching something or tried talking in front of people, but when people are on their computer or on their phone all the time, it's distracting. So if you're going to be surfing the net the entire time or on your phone texting the entire time, then just don't come. Everything's on YouTube anyhow, right? Most of the time, right? So if you're gonna come, pay attention. Some people actually like the YouTube format because you can pause the video, go back, rewind it, you know, you can go at your own pace. Some people are, you know, do the opposite. They fast forward through the explanation, just want to get to how to do the examples, right? So that's fine. I mean, some people find just watching the YouTube video is actually more effective than coming to class, right? It doesn't really matter, right? As long as you come to class, you got to pay attention. If you don't come to class, then watch the YouTube videos. But you got to do something. You can't not watch the YouTube videos or come to class, right? You have to do one of those two things, right? All right. So does everyone have? And the other thing that I want to mention is that at the beginning of class, I'll discuss things, right? Logistics, like, you know, when the next test is. I mean, you should know when the tests are, but I'm just saying. I'll remind you the next test is Tuesday. I'll, you know, go through a little bit of information, you know, for a minute or two. So it's your job to watch that on YouTube. If you don't come to class, you need to, you know, keep up with the class too, right? So don't send me emails about, you know, or, you know, something that I mentioned in class is what I'm trying to say, right? Because you have to watch the YouTube videos if you're not going to come to class. And on Canvas, I'm going to post it after the class. There's going to be this thing called a responsibility quiz. It's a stupid little thing. It's like an end user license agreement for this class. So it's just a little quiz. It doesn't count for anything. It doesn't count towards your grade. But it's just to make sure that you understand the class policies and the syllabus and how the class works. And you have to answer that quiz. It literally takes 2 minutes or a minute. You just go yes, 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 yes. And when you answer that quiz, it unlocks the lectures and everything. In other words, you won't be able to see the lectures unless you take that little responsibility quiz, right? Which is, by the way, what I was working on before class. There was a notification that popped up. Whenever I do anything in Canvas, it sends out a notification, whether I want it to send out one or not, right? So unless I send out a notification from myself, don't pay attention to all the notifications you get from Canvas. All right, so that's pretty much it. The last thing I want to talk about is, so after you take a test, obviously grade the test, or hand the test back, and on Canvas, after every test, they're going to update your average, right? So you have a quiz average and a test average, and then you have this weighting policy that I do, right? Which is, where is it? Here, right? This weird weighting policy. So then I'm going to use that formula to basically calculate your average, right? With your quizzes and tests. And I'll put that on Canvas as well, right? Your overall average with quizzes and tests factored in. And this is how the grade breaks down. That's the grades that you need to get an A or whatever. So basically to get an A, you need a 91.5 or higher. But that's not that hard to do because everything is more than 100 points anyhow, right? So if I say your overall average on Canvas is 105, which is hopefully what most people have in here. I don't know. But that's out of 100, right? It's not 105 at 110 or something. If you have 105, it's 105, right? You don't have to renormalize your grade, right? That's your grade. Whatever grade I put on there is your grade, and you use this grading scale to figure out what your letter grade is, right? Is what I'm trying to say, right? So I don't scale either, right? I might scale like 1/10 of a point or something. If you have a 91.4, I'm usually not that bad of a person. I'll usually give you the A, but I'm not going to, if you have a 86.5, I'm not going to scale you up to an A is what I'm trying to say, right? If you're reasonably close to the next letter grade, I'll probably scale, but otherwise I'm not, right? All right, so are there any questions on anything so far? So like I said, this syllabus will be on Canvas later on, right, after class, right? You can read it again if you want to. All right, so there aren't any more questions, right? All right, so what we're going to do is start a little bit of physics today, right? Has anyone taken physics before? All right, good. All right, so for those who've taken it before, some of it might be repetition, things you've seen before. You might be a little bit bored, but there are some people that haven't seen any of this before, so I have to start from scratch, right? Normally sometimes in a physics class you go over measurements, what units are and all that stuff. I assume you know what a kilometer is and what a meter is. I mean, this stuff you should know, right? Everyone knows those units, right? And sometimes you go over significant figures, which is important for labs and measurements, but for me, we're just doing theoretical calculations here, and significant figures aren't that important to me. They're important to some people, but not to me. So usually we just use a couple decimal points, and that's good enough, right? We want a general answer, but I don't really care about how accurate the answer is in general. So I'm going to skip all that and just start actually talking about physics, right? Okay, so I use this program here. So this is what I'm talking about. See, this is basically the book. So you don't have to copy this. By the way, you shouldn't really write any notes, or at least you shouldn't copy everything down, right? You should make notes to yourself, right? But you shouldn't copy everything down because this is going to be posted on Canvas, right? I'm going to turn this into a PDF and post it on Canvas. Everything that's written here, everything I write down is definitely going to be on Canvas, right? So you shouldn't copy everything because when you copy everything, you miss things, right? That's the reason why I do this. But you should make notes to yourself. If you're confused about something and you make a note to yourself, you know, that's fine. But you shouldn't write everything down. Yeah. Not in general, but I could probably start doing that maybe. Yeah. So basically, you know, I can write on this thing too, right? So this now you have the Microsoft Surfaces, but I've used this thing forever before. The Surface, and people sometimes don't know what I'm doing just yet. But anyway, everything I write will be printed as a PDF, right? All right, so basically we're going to start with vectors today, and pretty much this is what we're going to do today and finish it tomorrow, or maybe finish it today. We'll see how we go. But anyhow, so a vector is an extremely important quantity in physics. But by the way, does everyone know what physics is? Sometimes I introduce physics. Everyone has a pretty good idea what we do in physics, right? It's a study of the natural world, basically, trying to figure out how everything works. Okay, so in order to study the natural world and do physics, we have to understand what a vector is, right? Because a vector is, and we'll get more into it in the next few minutes, but in general, it's something that has an amount and a direction. So directions are important because just naively, if you consider a car crash, right? If two cars are going, say one car is going 60 miles per hour, one car is going 50 miles per hour, right? So the one that's 60 miles per hour is behind the one that's 50, right? If they're going in the same direction, obviously the 60 mile per hour car's got to catch up to the 50 mile per hour car, right? But the accident won't be that violent because you're going in the same direction, right? But if they're going opposite directions, 60 and 50 miles per hour, and they hit head on, that's going to be a much more violent collision just by common experience. So, you know, when Newton was coming up physics, he realized that, you know, direction matters in physics, right? So you have to come up with a new thing that takes into account direction, which is this thing called vector, right? So vectors are important in physics. We use them a lot, and you have to understand what they are and how to do vector algebra math with them, basically, is what I'm trying to say. So figure that out today. So like I said, a vector has two things, right? It has an amount, which we say is magnitude. We can amount, magnitude are the same thing, synonymous with one another. And a direction, right? So there are all sorts of different vectors. One of them is displacement vector, which we'll talk about in a bit. One of them is velocity vector, one of them is acceleration vector. We'll talk about all these things over the next couple of days. But one vector is what's called a displacement vector. So displacement vector is something that has a distance, right? So the magnitude is a distance, and the direction is how you have to go to get from point A to point B. So for instance, if you go from here to West Palm Beach is about 20 miles north, right? So that's actually a vector, right? 20 miles north, due north, is the vector. 20 miles is what we say is the magnitude of the vector, how much the vector is, right? How far you have to go to get from here to West Palm Beach. And north would be the direction, right? So there's two things. If you just say it's 20 miles, that's not a vector. You need two things, 20 miles and the direction, which is due north. So that's, you know, a simple example of a vector, but we have to sort of create a more sort of rigorous definition or a better way to say that, right? Because that doesn't work that well if you're trying to do calculations. So this is how we start doing this, right? So there's a couple ways to do this. We'll see a few different ways. But usually you write a vector, you represent a vector as an arrow, right? So this is a generic vector. So they're all different sorts of vectors. And we'll see them, like I said, over the next couple of days. But this is just a generic vector. It's not anything. It's not a distance. It's not a velocity. It's just some vector, just general. This is a vector, right? You can say it's vector A, right? So you write vector A as an arrow. And you usually start it at the origin of your coordinate system. So here's the origin here. And you represent it as an arrow starting at the origin. So the arrow, the direction of the arrow represents the direction of the vector, right? So in this case here, it's saying to get from this point to this point, I have to go in this general direction here, in the direction of A, right? Basically, it's northeast or something, right? It's pointing northeast. And the length of the vector is related to the magnitude. So in other words, if you make this vector twice as long, then the magnitude is twice as big, right? If you make it 3 times as long, it's 3 times the magnitude. If you make it half as long, it's half the magnitude, right? So the length of the vector is related to how far you have to go if you're talking about displacement vector. Or just in general, for magnitude, the length of the vector is related to the magnitude, right? If you half the length, you half the magnitude, right? If you make the length 4 times bigger, the magnitude increases by 4. Does everyone understand what I'm saying? Is that? Okay. So that's the first thing we got to do is figure out how we represent a vector, and we represent it by this arrow. Now, when you're writing it, you represented it, the vector with basically a half arrow over it, just like I wrote here, right? This little mark here, like that. That's how I write it. Would be how you write the vector, vector A. When you're typing it, sometimes you can set that as part of the typeface, that arrow, but normally what you do is you write it as a bold letter, right? So when you see it typewritten, a bold symbol would represent a vector quantity, right? Otherwise it's not a vector, it's something else, right? Okay, so that's the vector. Okay, so now we have to figure out how we actually mathematically write a vector, which we'll get to in a minute, but let me just say one more thing. Vectors only depend on their magnitude, which is basically how long the vector is, and the direction of the vector, right? So normally you draw the vector starting from the origin, like I showed you. However, it doesn't matter where they start. In other words, all that matters is how long the vector is and the direction of it. So I can take this vector and move it to here, and it's the same vector, right? Because it's the same length, it goes in the same direction, right? I can move it to here, right? It's the same length, it's the same direction. All these vectors are the same length pointing in the same direction, right? So it doesn't matter where the vector starts, as long as it's the same length and it's pointing in the same direction, it's the same vector. These aren't different vectors, it's the same vector, right? But like I said, by convention, you normally start drawing a vector from the origin. That's how we usually do it, right? But it doesn't have to be like that, right? All right, does everyone understand so far? Okay. All right, so this is how we start doing the math associated with vectors, right? So this is one way. There's actually 2 ways to do it, but this is the basic way, and I'll briefly go over the other way. So using trigonometry, what we can do is we can take a vector and break it into 2 perpendicular components. In general, it can be any 2 perpendicular components, but usually we use the x and y direction as the 2 perpendicular coordinates. So basically, you have this vector A, and you want to figure out how much of it is in the x direction, right? And then you want to figure out how much of it is in the y direction, which are perpendicular to one another. So what you do is you make a right triangle with the vector itself, right? So here's the vector A. It's the same vector as this. Same thing. All I did is I drew a line that goes vertically at the end of the vector and a line that goes horizontally starting at the origin, right? To give you this picture here, right? So how far you go along the x-axis, right? This line here, this line from here to here, is the x component of the vector, which we say is ax, right? Ax means how much you go in the x direction. That's all that means, right? And then ay, which is the length of this line here, from there to there, is what we say is the y component of the vector, or how much you have to go in the y direction, right, for that vector. So that just forms a right angle because x and y are, of course, perpendicular to one another, right? So because that forms a right angle, this makes a right triangle, right? Where a, which is basically the magnitude of the vector, how long the vector is the hypotenuse, right? And then what you can do is you can draw an angle, right, between the x-axis and the hypotenuse. And if you know that angle, then you can use trigonometry to figure out what is the x part of that vector and the y part of that vector. It's the magnitude or the hypotenuse, A, times the cosine of the angle because it's adjacent, right? Does everyone remember trigonometry? Hopefully, yeah. Okay, so because it's adjacent to this angle that I drew here, it's cosine, right, for the x part, and then the y part is opposite of this angle, right? So it's sine, right? So that's how you figure out exactly how far you go in the x direction, how far you go in the y direction to form that vector, right? So ax is a cosine theta, ay is a sine theta, right? So this is the x component is what I said is ax, and ay is the y component. It's basically just how far you go in the x and y direction, right, to form the vector. So that's where we start from. And then what you can do is rigorously sort of write down the vector like this, right? So the vector A, in this case, is ax plus something, which I'll explain. And then ax actually times something, which I'll explain in a second, plus ay times another thing, which I'll explain. So these little things, this thing here and this thing here, are called unit vectors, right? So x hat, so this is a hat, by the way. This thing here, when you write like that, that's what we say is hat. So x hat, which is this thing, and y hat, which is that thing, are called unit vectors, right? So what is a unit vector? A unit vector is a vector that's 1 unit long, so it has, the length of it is just 1, right? Whenever you have a hat over something, like this, it means the length of it is 1, right? And for x hat, it's just a vector that has, it's 1 unit long that points in the x direction, positive x direction, and the y unit vector is a vector that's 1 unit long and points in the positive y direction. So the x hat vector looks like this, and the y hat vector looks like that. So there are little arrows that are 1 unit long that point in the positive x and positive y direction. But what they mean in general, and you'll see how this works in a few minutes, is they basically just mean in the x direction and in the y direction, right? So in other words, when you write this vector A, you can say, if you literally were telling someone how to write the vector A, you would say it's this much in the x direction and then this much in the y direction, right? So this x hat actually, you can sort of translate it to be in the x direction. And the y hat, you can translate it to mean in the y direction, right? So A is ax in the x direction plus ay in the y direction, right? That's all that means, right? You don't have to really get into it more than that, as long as you understand what the x hat and y hat is. But you can't write the vector without those x hat and y hats, because it doesn't make any sense. In other words, if you wrote the vector A as ax plus ay, without the unit vectors like they should be, that's wrong, because it doesn't really make any sense. What you're saying is all you're doing is taking ax, whatever that number is, and adding it to ay, right? Which isn't what a vector is, right? It's just that would just be a number, right? If you're just adding two things, which is just a number, which isn't a vector. So you need the x hats and the y hats there to represent the vector, right? Does everyone understand? Okay. Now one thing I want to say, I forgot to say, and I'll go back, is that ax and ay can be positive or negative. Does anyone know why they could be positive or negative? All right, because the direction, if you rotate the vector so it's in the second quadrant, then the x part is negative and the y part is positive, right? If you rotate the vector so it's in the third quadrant, then both of them are negative, right? If you rotate it, both of them are negative, right? If you rotate it in the fourth quadrant, the x is positive and the y is negative, right? So it depends on where the vector is pointing that determines the sign of the components, but they can be positive or negative, right? All right, so let me show you something quick. Sometimes I forget about this stuff. All right, hold on 1 second. I need to, this is good. All right, so let me make this bigger. So I do these little computer demos every once in a while. All right, it's a little bit hard to see, but I have a vector here. When I start to move it around, it's easier to see, and you'll see what's going on. And over here, it's tough to see my cursor sometimes, but there's an ax equals something, there's an ay equals something. That's the x and y components of this vector, right? So right now, it's, let me just, all right, you know what? I have to make it a little bit smaller. It's going to be hard to see the text, but I have to make it, all right. So right now it's just in the x direction, right? It's just in the positive x direction. It's tough to see, but it's just an arrow in the positive x direction. And the length of it is 1, see? It goes from here to here, it stops at 1. So that means the x component is 1, right? And the y component is 0, right? So why is the y component 0? Because there's nothing in the y direction, right? It's just all in the x direction, right? So if I take this thing and I rotate it, so this is the scale, by the way. I'm going to make it a little bit bigger. So it's 2 units long, right? So now it's 2 units long. If I make it back to 0, you can see it's 2 units long. It goes from 0 to 2, and the x component is 2, and the y component is 0. It's just easier to see. So if I rotate it, like to here, this is the x part here, the little blue line. It's tough to see. The blue line is tough to see, but the green line is the y component, right? So ax, in this case, is 0.55, and ay is 1.92, right? They're both positive, though, right? Everyone gets that, right? So then if I rotate it so it's 90, or at least pretty close to 90, let's see. Well, You get the idea. It's pretty close to 90, right? So if it actually was 90, what would the x component be, do you think? 0, right? Because there's nothing in the x direction, right? And it'll all be in the y direction, in the positive y direction, right? So that's pretty much what's going on here. The x component is very small, right? Because there's almost nothing in the x direction. And the y component is basically 2, basically, right? I'm a little bit off from 90, but you get the idea. All right, so then if I put it in the second quadrant, say over here somewhere, right? The x part is, of course, negative. This is what I was just saying before, right? So the x part would be negative, whatever it is. In this case, it's negative 1.85. And the y component would be positive, right? In this case, it's 0.74, right? And then if I made the angle 180, well, at least close to 180. All right, you know what? I can do that. All right, so it's at exactly 180, right? So what is the y component again? 0, because there isn't anything in the y direction, right? But what would the x component be? Negative 2, because the whole thing's in the negative x direction, right? So the x part would be negative 2, correct? And then in the third quadrant, both of them are negative, right? The x part and the y part are both negative, right? Because it's in the third quadrant, right? And then if I made it 270, what is the x part? 0, right? Because there's nothing in the x direction. What's the y part? Negative 2, because the whole thing's in the negative y direction, right? And then if I put it in the fourth quadrant somewhere, the x part is positive, but the y part is negative, right? So anyway, that's how the x and y parts can be positive or negative. But, and I'll tell you this again later on in the notes, but the magnitude is always positive. Like the length of the vector is always a positive number, right? And you'll see how that works out mathematically, right? Because you're just talking about the length of the vector. Lengths cannot be negative, right? The components can be negative, but the length of the vector can't be negative. But you'll see that. You'll see how the math works out in a bit. All right, so does everyone understand components? We'll do an example in a bit, right? We're going to do examples too. It's not just all lecturing. But I got to get through a few things before we do an example. All right. Actually, let me see what the example. Sorry, hold on one second. All right, that computer's waking up. All right, let's go back to here. Computer's waking up. All right, so let's skip to here. Why is this thing doing? Sorry, wait, this thing, my computer locked up. All right, so so we went through the components, and the x component is a cosine theta, and the y component is a sine theta, right? So if you know the components of the vector, so you might be thinking, why would you do this if you're usually given the length of the vector and it's an angle, and then you can find the x and y components, like I just showed you, a cosine theta and sine theta. So the question is, why would you ever want to find the magnitude again when you're usually given it? It's because when we do vector algebra, which we'll see soon, very soon, what you first do is find the components of the vector first. You actually are going to find the x and y components of the vector first, and then sometimes you might want to find the magnitude of the vector after you find the x and y components. So, like I said, this forms a right triangle, right? So if you know the x part and the y part, the magnitude, which is the length of the vector, which is the hypotenuse, is just given by the Pythagorean theorem, right? So if you know the x part, you know the y part, then you can use the Pythagorean theorem to find the magnitude of the vector. So this is why the magnitude is always positive, because if ax and ay are negative, you're squaring them, and you get rid of the negative, right? So ax and ay are both squared, right, and added together. It's a Pythagorean theorem. So the magnitude always turns out to be positive, right? The other thing I want to mention is that when you write the magnitude of the vector, you write it without the vector sign. So a with the vector over it means this thing here, ax in the x direction plus ay in the y direction, this whole sort of mathematical sentence. But a without a vector sign over it means the magnitude of the vector, right? So you just write a without a vector sign over it. It's just the magnitude or how long the vector is. All right, so what's going on here? Oh, there we go. Okay, so I'm going to do a little bit more before we do an example. All right, so the other thing you sometimes want to do is find the angle of the vector. In fact, that's the other way you can write a vector. You can say that it's so much in the x direction plus so much in the y direction, right? That's one way of writing it. I just showed you that. The other way of doing it is you could say it's a certain length at a certain angle, right? So in other words, suppose you know this angle is 30 degrees and you know the length is 5. You can say the vector is 5 units at 30 degrees from the x-axis, right? That's the other way to state the vector, right? Now, we normally don't state it like that often. You usually do it in component form like this. You usually say it's this much in the x direction plus that much in the y direction. But every once in a while, you write it as a certain length at some angle, right? So if you wanted to find the angle and you know the x and y parts, right, the components, then you can just use trigonometry, right? Because there's all sorts of ways to do it. But the standard way of doing it is if you know the y part, the ay and ax, the y and x component, then if you're trying to find this angle here, this side's the opposite side, this side's the adjacent side, right? Ay is opposite, ax is adjacent. So that's tangent, because the tangent of theta is the opposite over adjacent, right? So theta is the inverse tangent of ay over ax, right? But you got to be a little bit careful, because if you look at the equation I use here, I put an absolute value in. And the reason why that is because if ay and ax are negative, there's two ways you can get a negative answer from a quotient, right? So if ay is negative and ax is positive, and you divide them, you get a negative answer, right? If ay is positive, ay is negative and ax is positive, right? But it also works if, well, the converse, I forget what I said. Ax is negative, ay is positive, right? That gives you a negative answer too. Your calculator doesn't know which one is positive, which one is negative. It just sees the negative sign, right? So there are two angles which give you the same inverse tangent, right? In other words, let me just sketch it quick, right? So if ay is negative, so this vector here, right? You have a negative ay, I'm sketching it quick. But ay is negative and ax is positive. I write way more neatly when we do the example. I'm just sketching something out quick, right? All right, so that is one way to get a negative answer, right? In the quotient of ay divided by ax. The other thing you can do is if ax is negative, ay is positive. So this is ax is negative, ay positive, right? So when you put, when you do the inverse tangent, it doesn't know which one's which, right? Because your calculator only sees a negative sign, right? Both of these answers are the equivalent, right? According to your calculator, right? So the thing that you should do is take the absolute value of ay over ax, right? Get that angle. And that's the interior angle. That's either this angle or that angle. And then what you do is once you find that angle, you sketch out the vector. You just figure out what quadrant it's in. It's pretty easy to do. And then you can figure out, related to the quadrant, what the angle is from the x-axis, right? I'll give you an example of that when we do the example. But that's the best way of doing it. So that's where the absolute value comes from. All right. All right, we're eventually getting to an example, but I got to go through a few more things first. All right, so does everyone basically understand what a vector is so far? I mean, we'll do an example soon, right? But the general idea of what a vector is, right? There's an x and y part, has a direction and a magnitude, and an angle. So there's algebra you can do with vectors. You can multiply them by numbers, which are scalars. So scalars are not vectors. So vectors are basically things that have magnitude and direction. Scalar is the other quantity we see in physics. A scalar is just something that has a magnitude, right? So time just has a magnitude. It just has a, an hour is just an hour. It's not, there's no direction associated with time, right? So scalars are just basically numbers, right? Just ordinary numbers. So what you can do is multiply a scalar, a number, by a vector, right? So we'll figure out what it does to a vector. So suppose you have a scalar s, right? So it's the number like 2 or 3 or 4 or 5 or -1. It could be anything. And you multiply it by a vector. So you take a vector A and you multiply it by a number, 2, 3, 4, 5. So basically what happens is, this is vector A here. So basically what the equivalent of what you're doing here is you're taking the number and you're multiplying it times the x component, and you're taking that same number and you're multiplying it times the y component, right? This is what I have here. So if this is like a 2, then the x component is just 2 times bigger, and the y component is 2 times bigger, right? And that gives you the x and y components of b, right? The vector b, which is s times a. So the x part of b is just s times ax, whatever that number is, 2, 3, 4, 5, whatever. And the y part is just s times ay, right? So it's 2, 3, whatever times ay was, right? That gives you what the vector is. So what does it do to the vector? Well, if you find the magnitude of the vector b, which is bx squared plus by squared, so you have this vector b, it forms a right triangle, right? If you take the x part and the y part and you square it to find the magnitude and add it together, take the square root, just by algebra and simplification, you see it's b is just s times a. So it's pretty straightforward. In other words, if you take a vector and you multiply it times a number, all it does is just make the vector longer or shorter, depending on what the number is. So the magnitude or the length of the vector is just the number times the length of the vector, right? The magnitude of the new vector, I should say, is just the number times the magnitude of the old vector. That's all that happens. So basically, it just makes the vector bigger or smaller, right, if it's positive. I'll show you what happens if it's negative. All right, so, well, I'll show you right now. So if it's a positive number, what happens is it doesn't change the sign of x and y, right? If it's a positive number, s is positive, like it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't change the sign of the vector, right? Ax and bx have the same sign. Bx, by, and ay have the same sign, right? So that means the vector points in the exact same direction, right? If it's positive, right? B and a point in the same direction. But if s is negative, because this can be a negative number too, if s is, say, -1 or -2 or -3, then what happens to the signs? All the signs change because you're multiplying by a negative number, right? So if both signs change, what happens is the vector flips 180 degrees, right? So if you multiply a vector by a negative number, it also flips it around 180 degrees, which is also demonstrated here. The angle is either the same or off by 180 degrees. Anyway, so if you have a vector A and you multiply it by a positive number, it just makes the vector longer or shorter, depending on what s is. But the vector stays in the same direction. It points in the same direction as a. So if s is bigger than 1, the vector gets bigger, right? You multiply by 2, 3, 4, 5, 6, 7, 8, whatever, it gets bigger. If s is less than 1, which is like a half or a quarter, then the vector gets smaller, right? And then if the s is negative or less than 0, then b is 180 degrees opposite of a because the components change signs, right? But it's the same thing happens. The vector either gets bigger or smaller depending on what the absolute value of s is. So I also can show you that here. So here s, all right, let's make s 1. All right, so s is 1. So this is just the unit vector, vector that has a length of 1, right? Then if I make s, so s is the scalar that I'm multiplying this vector by, right? By the way, right? So if I make it 2, it just makes the vector twice as big, but points in the same direction, right? If I make the vector 0.5, that's 0.5, by the way, then it makes it shorter, but it points in the same direction, right? If I make the vector -1, right, it flips the vector 180 degrees, right, but keeps the vector the same length, right? So this is the original vector, right? This is length 1. This is -1. See? It just flips it 180 degrees, but keeps it in the same direction. If I make it -2, it gets twice as big, but it flips 180 degrees, right? If I make it -0.5, it's half as big, but it flips it 180 degrees, right? Does everyone understand that so far? Yeah.
For multiply by a scalar,
Mm-hmm.
does that change it to a different vector because it's a different magnitude?
Yeah, so say the original vector is A, right? And then the new vector would be B. Unless S is 1, A and B are different vectors, right? Positive one, I should say, right? So in general, they're two different vectors, right? B is S times A. All right, let me go for like maybe 5 more minutes, and then you guys take a break. And then we're getting to examples soon, but I want to do a few more things before we get to an example. All right. So, like I said, particular case, a special case of multiplying by a scalar is multiplying by -1. So if you multiply a by -1, it just flips the vector 180 degrees, right? Because the length is the same, but it flips it 180 degrees, right? Does anyone get that? Because you need to understand this for what's called vector subtraction. All right. Actually, that's pretty good for now, because the next thing I want to talk about is vector algebra, which is adding or subtracting vectors. And then after that, we're going to do an example on how to find components of vectors, how to add and subtract vectors, right? So why don't you take your break before we get to vector algebra, and then when you come back, we'll do vector algebra. So take a 10-minute break and come back. Start the video. All right, you guys ready? All right, so the next thing I want to do before we start doing examples, I'll show you how to calculate components with actual vectors in an example in a bit, and how to multiply by scalars in a bit. But before I do that, I want to talk about the next topic as far as vectors go, which is vector addition. It's another sort of important concept to learn in physics, because a lot of quantities that we see are going to be vectors, and we'll start seeing them probably tomorrow. And when things are vectors and you're trying to add vectors, which we do a lot in physics, you have to understand how this works. It's not quite as simple as adding numbers, right? It's a whole thing called vector algebra. So if you have two numbers, for instance, and you're trying to add them, this is pretty simple. We know how to do this. Now, if you have two vectors that are, and you're given the magnitude of two vectors, say one of them is 2 and one of them is 4, and you're saying, add these two vectors and see what they add to. It's not quite as simple as just adding the magnitudes up. You don't just add 2 plus 4. It's more complicated than that. But it's actually not so bad. So how do we add vectors first, right? So there's also vector subtraction, which I'll talk about later, but first we're going to talk about vector addition. All right, so basically how you add vectors, suppose you have two vectors, A and B. These are just two generic vectors. Later on, we'll see them as maybe velocity vectors or acceleration vectors or something. But right now, they're just two general vectors, right? And you're trying to add them to form a new vector, which we usually say is R. R means the result of adding vectors A and B. But it can be any vector. You could say it's vector C or D. It doesn't matter, right? A plus B gives you some other vector. Whatever you want to call it, you can call it. But like I said, usually we call it R, which means the result of adding vectors A and B. Okay, so how do you do this? Well, there's two ways to do it. One way to do it is graphically, right? So basically, if you have vector A, you usually draw vector A starting from the origin, right? So this is vector A here, right? This black vector is A. And then vector B is the blue vector. Remember, vectors, you can move them around, right? As long as they have the same length and the same direction, it's the same vector. So instead of drawing vector B at the origin, what you do is you draw it starting at the end of vector A, right? So here's vector B in blue, right? So you draw A, and then you put B at the end of it. And then what you do is you make a vector from where vector A starts to where vector B ends, which is the red vector there, which is vector R. And that is the vector sum of adding A and B. That's how you do it graphically, right? So R has some length to it, which you could measure if you wanted to, and it points in some direction, right? So you can measure the angle there if you wanted to. But that's just a schematic way of doing it, right? This is not usually how we do it. We have to do it, more rigorously than this. And you basically can do it by finding the components of A and B. This is the usual way we do it. So how do we do it using components? All right, so first of all, using trigonometry, you can figure out the components of vector A, right? It's just usually A cosine theta is AX and AY is A sine theta, right? Like I told you before the break. And then you can find the components of B. So B, X, the X part is B cosine theta, and the Y part is B sine theta, usually, right? So once you find the X and Y parts of A and B, it turns out, just by looking at it, the X part of vector R, so you can take vector R, the result of adding A and B, the red thing there, and make it into a right triangle too. And it has an X part to it and a Y component too, right? So this is the X component of R, from here all the way to here. It's tough to see. Anyhow, I'll just sketch it, right? From here to here is the X part of R, right? And then from here to here is the Y part of R. That's what I have here, right? Rx and Ry. So the X part of R is just the X part of A, right? Because this is the X part of A, right? And this is the X part of B. So if you add those two things together, you get the X part of R, right? They just add together. You go a little bit in the, for the X, and the rest of it is BX, right? So ax plus bx gives you the x part of r, right? Everyone get that? And then this is the y part of a, and this is the y part of b, right? So if you add these two things together, you get the y part of r, right? So what I'm trying to say is if you find the x and y parts of a and the x and y parts of b, to find the x and y parts of r, the components of r, then you just add them together, right? The individual components. So that's what I have written here, right? So to find the x part of r, you just add the x parts of a and b, and to find the y part of r, you add the y parts of a and b, right? So that gives you the vector r. Now you can write it as a vector. You can say it's this much in the x direction and then this much in the y direction, just like an ordinary vector, right? And that's how you actually figure out what the vector r is. Now a lot of times you want to figure out what is the magnitude of vector r, which, well, how would you find the magnitude of vector r, how long vector r is, if you know the x and y parts of vector r? Use the Pythagorean theorem, right? I mean, you can see it here. This is just a right triangle, right? You have the x part and the y part, right? So if you take the x part squared, add it to the y part squared, take the square root, that gives you the length of vector r, right? That's how you find the magnitude of vector r, right? Does everyone get that? Okay. So what if you do sort of, oh, sorry. So vector addition is cumulative. In other words, commutative, sorry, not commutative. Commutative. Vector, if you add vector A and vector B, it's the same as adding vector B and vector A, right? So it doesn't matter which one you start with, right? Vector addition is cumulative, just like ordinary arithmetic is cumulative. 2 plus 4 is the same thing as 4 plus 2, right? Okay, so let me show you how this works a little bit. So here, all right. So I have two vectors here, right? Vector A and B. So A is black and B is blue. So right now, vector A has a magnitude of 1 and vector B has a magnitude of 2, right? Does everyone see that? Vector B is 2 units long, vector A is 1 unit long. So if I, sorry, I have to go down here. All right. Yeah, same thing though. Vector A is 2 units long. Oh, yeah, so anyhow, okay, so vector, so what I'm doing here is I'm doing vector addition. Sorry, I forgot what I did here. But what I'm doing is I'm putting vector B at the end of vector A, right? This is slightly different than what I just showed you, right? So vector A is 1 unit long, vector B is 2 unit long, but I'm putting vector B at the end of vector A to show you vector addition, right? So A is here, it's 1 unit long, and vector B is 2 units long, so the result is 3 units long. If they're in the same direction, right? They just add because they're in the same direction, right? Okay. So, but if I rotate this, this is how you do the vector addition. So this is vector A, and this is vector B, and vector R is in red, right? So that's the vector sum of those two things, right? Now what I'm going to try to show, well, actually not here, but anyhow, so this is just the sum of vector A and B, and this forms vector R, and you can measure the length of vector R, and that gives you the magnitude of the vector, and you can also find the x and y parts of R. So the x and y parts of R just come from adding bx to ax, that gives you rx, and adding ay to by, that gives you ry, right? Does everyone get that? So by rotating this vector around, right, so I can do all sorts of things. But that's how you add these two vectors up, right? The red vector is the magnitude of, or the sum of those two vectors, right? Is what I'm trying to say, right? So unless they point in the same direction, right? So let me adjust this. See, it doesn't matter, they don't have to be on the x-axis, right? If they point exactly in the same direction like this, then their magnitudes just add together, right? In other words, the magnitude of vector R is just 1 plus 2, right? Approximately, right? Because they point in the same direction, right? But if you're at any other situation like this, the magnitude of R is not just A plus B, right? You have to find the x and y components and then do the Pythagorean theorem, right? Does everyone see that? Okay. All right. So let's go back here. All right, I'm going to do a couple more things, then we're finally going to do an example. Uh-oh. Every once in a while, my screen locks up, which is not good. All right, there it goes. So yeah, that happens every once in a while. I do have some technical problems from time to time. But, okay, so what if you're doing more than 2 vectors, right? So you can, there's no rule about how many vectors you can add. You can add 4 vectors, 5 vectors, 6 vectors, 7 vectors. So the question is, how does it work if you have, say, 4 vectors, right? So you're adding A plus B plus C plus D to give you a vector R, right? It's the same idea. To do it graphically, all you do is you start a vector with vector A, then you put vector B at the end of vector A, then you put vector C at the end of vector B, and then you put vector D at the end of vector C, just as it's spelled out here. And the sum of those vectors is just a vector that goes from where vector A starts to where the last vector ends, which is vector D. So this would be vector R, right? That's how you do it graphically. Now, if you're trying to do it actually figuring out the answer with components, all you do is find the x and y part of A, B, C, and D, and then you use this general idea. So the x part of R would just be the sum of all the x components, right? So to find the x components, you just do cosine and sine, basically, right, for each one of them. And then you just add them up, the x parts, and that gives you the x parts of R, and you add up the y parts, that gives you the y part of R, right? So it doesn't matter how many vectors you have, it's the same basic idea. Now, what about vector subtraction? So if you're trying to subtract 2 vectors, right? So you're taking A and subtracting B, you're not adding B. Well, vector subtraction is a special case of vector addition, just like subtraction is a special case of addition as well. So 4 minus 2 is the same thing as 4 plus minus 2, right? You can add negative 2 to 4, and that gives you, that's the equivalent of subtracting 2 from 4, right? It's the same thing here. So if you're trying to subtract vector B from A, it's the same thing as adding negative B to A, right? So if you have, uh-oh, my computer's getting a little bit wonky. So if you have, let's go back to here. So this is A plus B. Suppose that this is B, right? And you're subtracting B from A. What you would do is you would multiply B by negative 1, right? Because that's negative B, right? So what does multiplying by negative 1 do? Does anyone remember from before the break? It flips at 180 degrees. So basically all you do is you take negative B and you add it to A. So that's what I did here, right? So negative B is just that vector flipped around 180 degrees, and then you just add it to the end of A, just like you did for vector addition. And that's vector subtraction, right? That's how you do vector subtraction, graphically. Now, it's pretty easy to do with components. If you have 2 vectors A and B and you're trying to subtract them, then it's the same thing. You find the x and y parts of A, and you find the x and y parts of B, and you just subtract them. You take the x part of A and you subtract the x part of B to find the x part of R. If you want to find the y part of R, you take the y part of A and subtract the y part of B, right? And then that gives you R. A minus B is R. Now, subtraction is not commutative, though. So in other words, A minus B is not the same thing as B minus A. You can do it algebraically. They're off by a sign. But anyhow, the point is, just like ordinary arithmetic, if 4 minus 2 is not the same thing as 2 minus 4, right? You're off by a negative sign, right? 4 minus 2 is 2, 2 minus 4 is negative 2, right? So the order matters when you're subtracting, just like it does in normal arithmetic. But when you're adding, the order doesn't matter, right? You can add in any way you want, right? All right, there's one more thing that I'm going to talk about, and then we're going to do an example, finally. So you can do more complicated things. So you can do a vector equation where you have scalars in there as well. So for instance, you have an equation where you're taking vector A, you're multiplying it by a scalar, so some number, times vector B. And then subtracting, so this is just a general random equation I wrote down. It doesn't come from anywhere. I'm just demonstrating something. Minus C plus vector D times another scalar, so a number, some sort of number, like 2 or 3 or 4. Then you could easily sort of, how you would figure out the answer to this problem, what vector R is. You first find the x and y part of R by using the same equation that you used here. So for instance, the x part of R would be ax plus this vector, the scalar b times bx minus cx plus the scalar d times dx. That would give you the x part of R. So whatever the equation is, it's the same equation to find the components, right? And then the y part of R is the y part of A plus B times the y part of B minus C, the y part of C plus D times the y part of D, right? And that would give you vector R, right? The x and y part of it, and then you can find the magnitude of it by doing the Pythagorean theorem. Now, the other thing you can do is you can actually solve for vectors as well. So for instance, if you had this vector equation, vector A plus B times vector B minus C plus D times vector D, you can solve for vector A, right? Suppose you know vector R, you're given vector R, right? And you want to find vector A. So it's the same thing. It's basically, you're basically doing algebra with vectors. So basically it's the same idea. You just have to be careful that they're vectors. So how would you find vector A? You would subtract everything else in the equation, right? So you would subtract B from both sides, you would add C to both sides, and you would subtract D, lowercase d, capital D vector to both sides, right? So you can do that. That's allowed in vector algebra. And you can even solve for vector B. Vector B is multiplied by a scalar. So what you would do is you would solve for B times B, right? You subtract A, add C to both sides, and subtract D times D to both sides. You get this. And then to find vector B, you divide everything by the scalar B, right? So all those vectors on the right-hand side will be divided by B, and that would give you the x and y parts of B, right? Does everyone get that? In other words, you can do normal sort of algebra vectors. As long as you remember the vectors, you have to find the x and y parts of them. All right, so finally, I'm going to do an example, right? We're going to do components. We're going to add vectors and subtract vectors. All right, so hold on. All right, so I type when I can type, but sometimes this typewriter does weird things. So hopefully it works today. Sometimes it is really laggy. All right, so let's see if it works. All right, I'm going to sit down for the example because it's just easier to write when I'm sitting down. Otherwise, I'll stand up, right? All right, so this example is, all right. All right, hold on a second. All right, there it goes. All right, I just had to reset it. Hopefully I just have to reset it. This thing is just working. All right, hold on one more time. There it goes. All right, so it's going to be super laggy, I think, but we'll see how it goes. All right. All right, so vector A. So it's supposed to be boldface, but I can't boldface what I'm typing. I mean, I could if I do the shortcuts, but it's a pain in the neck too. So that's supposed to be boldface, so it's not. Magnitude of 10. All right, so sorry, this thing is going to be weird. And
Make more space where,
what was that?
is it not like going through?
I don't know what's going on with this thing. Sometimes it works. I mean, you could see it just working, right?
I heard you typing it, but I didn't see it on the screen.
All right, so there it goes. All right, wait. And is directed at an angle of 60 degrees from the positive x-axis. Counterclockwise. I'll tell you what that means. I always go counterclockwise. It's by convention, just so we have a common way to measure angles. Counterclockwise from the positive x-axis. Okay, so vector B, you really don't have to copy all this down. It's going to be printed and uploaded. It has a magnitude of 5 and is directed in the negative x direction. And vector C has a magnitude of 8 and is directed at 60 degrees from the negative x-axis, counterclockwise, right? Because you can go clockwise or counterclockwise. But the convention is you always usually go counterclockwise. All right, so that's sort of the given information. We're going to ask a whole bunch of questions related to these vectors. So, I mean, you don't have to do this, but it helps to do this, which is sketch the vectors, right? So for the quizzes and tests, it just helps to sketch them, and then you can figure everything out from there. All right, so let's sketch the vectors, right? So this is how I would do that. We're going to start easy. So basically, you draw a coordinate axis. All right, I'm going to change that to black. All right, so you start with your axis, right? So this is y, this is x. And then you just draw the vectors that are, you kind of want to draw them to scale. What I mean by that is that vector A has a length of 10, and vector B, say, has a length of 5, right, magnitude of 5. So that means that vector B should be approximately, right, half as long as A. Or in other words, A should be twice as long as B, right? Because the magnitude of A is twice as long as B, right? So when you're sketching it, let's say this is vector A, right? So I'm going to color code this and use. So there's all these drawing tools here, which are good and it makes it look nice, but sometimes they work weird. So bear with me if it's. So I'm just drawing them all from the origin. That's typically how you first sketch them. So this is vector A, right? Because it's 60 degrees from the positive x-axis, right? So that's vector A, right? Everyone get that? Now, vector B has a magnitude of 5 and is directed completely in the negative x direction, right? So what I'm saying, like I said, 5 is half of 10. So if you're drawing it, you know, sort of accurately, you want vector B to be about half as long as A, right? I mean, it's just a sketch, right? But everyone understands what I'm saying? Okay, so let's draw vector B. I'm going to draw it in a different color so it's easier to see. If I can, oh, I'll just use this color. Oh wait, that's not going to work. Sorry, I have to switch it here. Oh no, it did work. Okay, so vector B is just in the negative x direction. And it should be, I can't see what I'm doing because my pen is blocking. That didn't work. Yeah, so sometimes, like I said, this thing doesn't work perfectly, and I have to do it a couple of times, but just try to. All right, there I can see. So, all right, so that's about, well, it's a little bit more than half as long, but you get the idea, right? It should be shorter, approximately half as long. Nah, I'm gonna make it shorter, sorry. That's gonna annoy me. I wanna make it look better. All right, one more time. All right, that's better, right? That's about half as long. Oh, man. No, it's shift makes it horizontal, but then you gotta hit escape, or else it keeps the, it's some bug in this program. So I gotta remember. All right, there we go. All right, so that's vector B, right? And then vector C is a length of 8. So 8 is somewhere between B and C, right? I mean, A is 10, B is 5, so 8 is, you know, a little bit more than halfway between the length of vector A and B. But we're not going to get that perfect. But anyhow, it's 60 degrees from the negative x-axis counterclockwise. So this is vector C. I'm going to try to get it pretty good, but let's say like that. That's pretty close. Oh, it should be exactly opposite of this one, though, right? If I want to make it perfect. Like that, right? So this is 60 degrees, and this is vector C, right? So that's how you sketch the vectors, right? All right, that's not that hard, right? Hopefully. All right, so everyone with me to this point? All right, so then part B, if this keyboard works, yeah, it works, is find the components. Because whenever you're given a vector problem, the first thing you want to do is find the components of the vectors that you're given. And we're going to practice writing the vectors in component form. So component form is the x and y parts and the x with the x hats and the y hats. All right, so the good thing about this is I can copy and paste. So what I'm going to do is copy this. And what we're going to do is we're going to just do them one by one and focus on, say, vector A first, since that's first in alphabetical order. All right, so I'm going to get rid of this and this. Well, all right, so this vector shouldn't be here because I'm just focusing on vector A. All right, so how do you find the x and y components? It's pretty straightforward. You just make a right triangle, right, with that vector. All right, so I'm just going to hand draw. I can use the tools to make it look nice, but it takes too long, so I'm just going to do it by hand. So this is the y component. And this here is the x component, right? So they're both positive, right? Everyone sees that, right? AX and AY are both positive. So how would you exactly find AX? Like, how would you calculate it? I'm going to switch to black. So AX would be, is it adjacent? Or it's adjacent for this case, right? So it's going to be, how would you figure out the length of AX, how long it is? It's going to be the length of A, which is the hypotenuse, right? Times the cosine of that angle, which is 60 degrees, right? So the length was 10, right? All right, yeah, it's 10. So it's 10 times the cosine of 60. Does anyone know the cosine of 60? The cosine of 60 is the sine of 30. Anyone know the sine of 30? 1/2, right? So it's 5.00. So most people, some people would have a problem with significant figures and everything. I really don't care about them that much. As long as I usually just do 2 decimal points, and that's good enough. All right, so, and then round after 2 decimal points. So that's AX, right? So how would you find AY? Oh, and it's positive, right? Because both the components are positive, right? It's in the first quadrant. So how would you find AY? It's a sine theta. So it's 10 sine 60. And that's 8.67. It's positive 8 that's an 8, right? Positive 8.67, right? So then you can write the vector A. If you're asked, how do you write the vector A? It's AX y hat plus AY y hat. So it's 5.00 x hat plus 8.67 y hat, right? So does everyone see that? So that's the answer for vector A. All right, so I'm going to box that. All right, so that's basically how you write down vector A in component form, right? All right, are there any questions with vector A so far? No? All right, so then do vector V, but vector V is really easy, hopefully. And no one has a problem with vector. All right, so I think they're all here. All right, so I'm just going to raise vector A and vector B, C, sorry. All right, so there's vector B, right, by itself. All right, this is easy, right? Whenever you have a vector on an axis, you don't have to do cosine or sine, right? It should be obvious how it goes. So what is BX? The length of b, by the way, is 5, right? Because you can't see the problem anymore. But the length is 5, right? So what would be x, but what would the x component of b be? Right, it's negative 5, right? Because the whole thing's in the negative y direction, negative x direction, right? So what would the y part be? Right. Right? So you would write b, you know, in general, although for this case it's really easy. So it'd be negative 5 x hat plus 0. But if it's if something doesn't have a component, you can just leave that out, right? So you can just write it as minus 5x hat, right? That's it, right? All right, so that's b. B is pretty easy. So whenever you have a vector that's completely in one direction, you don't do any trigonometry, right? You just look at it. All right, then let's do vector c. All right, so I'm going to erase A and B and just focus on C. All right, so I'm going to just hand draw the components for vector C. So this is the y part. I do the y part first, doesn't matter. So this is the y part, sorry, C. And this is the x part, and this is a right angle. So how would you find the, it doesn't matter which one we do, but let's do the x part, right? So how would you find the x part of vector C? It'd be, all right, so first of all, is x part negative? Yeah, and the y part's negative too, right? They're both negative. This would be minus c, right? Because they're both negative, right? You have to make sure that they're both negative, times the cosine of that angle, right? Of theta, theta c technically, but 60 degrees, right, is what I'm trying to say. So it's minus 8, because the length of, or the magnitude of vector c was 8, right? And then times the cosine of 60, which is negative 4, right? But the point is you have to write in the negative, right? Because it definitely has a negative, it has a negative x part and has a negative y part. And then cy would be minus c times the sine, right? Because once again, the x part is adjacent, the y part is opposite. That's why it's cosine and sine. So it's minus 8 times the sine of 60, and it's minus 6.92. So we do 2 decimal points and a round off after 2, right? That's what I'm doing there. So then C would be Cx, x hat plus Cy, y hat, which is negative 4.00. All right, this is 4.00. All right, so if the y part's negative, this is the typical way of writing it, right? So it's negative 4 x hat minus 6.292 y hat, because the y part was negative, right? That's where the negative comes from, yeah.
I have a question about the angle of C.
Yep. So, yeah, let me go over that. So if you go back and read the original, all right, so it's 60 degrees counterclockwise from the negative x-axis, right?
So why we didn't start at the same point as we went counterclockwise for A? So aren't you supposed to just go down on the right side of the X?
Here? On the negative x-axis, is that what you're saying?
I mean, fourth quadrant. Don't we go just down there?
That would be clockwise from the positive x-axis. So if it's 60 degrees clockwise from the positive x, that's going, yeah, that's the fourth quadrant, right?
Yeah.
But we're going 60 degrees counterclockwise from the negative x-axis, right?
So that's
So-
for A, right?
Right, so you're starting at the negative x-axis and you're going counterclockwise 60 degrees from there.
And if we start from the same point, don't we end up at fourth quadrant?
If it's 60 degrees?
If it's 60 degrees negative, which is clockwise, so we go down.
But it's not negative 60. So yeah, I mean, that's the other way you can do it. You could say C is, has a magnitude of 8 at an angle of negative 60 degrees, right? And that's, negative means clockwise from the positive x-axis.
If we go
Right, but it's not negative 60.
Oh,
It's 60 degrees from the negative x-axis.
Oh, I see.
Get it? Okay. Yeah. So I'm always going to do positive angles, which means counterclockwise, right? You always go counterclockwise, right? All right. Does that make sense? All right. So that's the first thing you need to do is figure out the x and y components. All right. So now we're going to get more complicated. Okay. So all right. So it's too hard to type this, so I'm just going to write it. So R is going to be B minus 2A plus 1/2 C, right? So what we want to do is find the x and y. Now my keyboard's working perfect, and I don't understand this thing. Of vector R, right? Okay. So this is just some random equation. It comes from nowhere. I just made it up. But the point is, if you're given this equation, b minus 2a plus 1/2 c, and you're trying to find the x part of R, then you just look at the equation, right? So the equation is b minus 2a plus 1/2 c. So that means the x part is the x part of b minus 2a times the 2 times the x part of a, because it's minus 2a, plus 1/2 the x part of c, right? That's what that means, right? You just use that equation and that gives you the x part of R. So we found the x and y parts of all these vectors, right? We found cx, we found bx, and we found ax, right? And we also found the y parts of all these vectors. There's ay, by is 0, ay is that, right? So we know the x and y parts. So it's just plugging into this equation, right? So you just got to be careful because sometimes, you know, I do it too. I switch the x and y part, x and ax and bx if you look at it too quickly. But if you're careful and you're, you know, just paying attention, you plug in each thing as it should be, then it's not so bad, right? This is minus 5.00 minus 2 times ax, which is plus 5. So that's plus 5 because it's minus, actually minus 15, right? Minus 5 minus 10 plus 1/2 of 1/2 of c, right? And cx was negative 4. So you put all that in your calculator, you can just do it in your head. This is minus 5 minus 10 minus 2, right? So it's what? Right? So that would be the x part of R, right? So how would you find the y part of R?
one more.
Yeah, it's basically the exact same thing. I'm going to cheat a little bit because you guys can print this out later. But the y part is the same thing. It's the y part of b minus 2 times the y part of a plus 1/2 the y part of c, right? So you just plug that in, right? Ry was, by was what? 0, right? So 0 minus 2 times ay, which is 8.67 plus 1/2. This is, it looks like a 4. That's supposed to be cy. And this is negative 6.92. So I'm just going to write it here. So that works out to be, that's a little bit harder to calculate in your head, but it also works out to be a negative number, right? It's negative 20.78 if you round off after 2 decimals, right? Okay, so this is the x part of R, and that's the y part of R, right? That's just how you find it, right? That's not too bad, right? All right, so that's how you do the calculation for Rx and Ry. Now we're going to do something with these values here. So the next thing we're going to do is, hold on. Well, this is easy, but let's do it anyhow. So the next part is pretty straightforward, but it's good practice. So write R, vector R, in component form. So that's really easy, but sometimes in some situations you want to actually figure out vector R, the x and y parts, and then write it in component form. So R in component form is how much our x is, which is negative 17. X hat, remember you need the x hat there. And then 20.7, negative 20.78 in the y direction, so it's minus 20.78 y hat, right? So this would be vector r, right, in component form. Like I said, that's hopefully pretty straightforward. All right, one of the things that you typically want to do, though, that comes up every once in a while, but this comes up all the time, is find the magnitude of vector r. Okay, so the magnitude of vector r is easy if you know the x and y parts. Does anyone know how you would find the magnitude of vector r if you know the x and y parts of it? Right, it's the Pythagorean theorem, right? So the magnitude of vector r, which by the way you write without a vector sign over it, is just the x part of r squared plus the y part of r squared, square root. It's the Pythagorean theorem, right? So once you've done all the work to find the x part, you just square it, and then you've done a bunch of work to find the y part. You square it. And then you put that in your calculator and you take the square root, and that gives you the length of the vector. So the x and y parts are negative, right? As they can be, right? But the magnitude is always positive, you know, for any vector that we do the entire semester. You can never have a negative magnitude because it's just a length, right? Lengths are always positive, right? So this vector is 26.85 units long, right? All right, so does that make sense? So by the way, if you're adding the magnitudes of the vectors up, it's 10 plus 5 plus 8, which is 23, right? But the magnitude of the vector is 26.85, right? Anyhow, the point is the magnitude of the vectors, something looks weird, but anyhow, the magnitude of the vectors don't add. You can't just add the magnitudes of vectors to find the magnitude of the vector, right? You have to find the x part, find the y part, square them and add them together. All right, so the last thing. Oh, that's why. Yeah, sorry, I forget we're doing this, right? It's b minus 2a plus 1 half c. But the point is you can't just take twice of a, half of c, and just use that equation, right, to find the magnitude of r, right? So b was what? b was 5, a was 10, right? And c was 8, right? So if you just put the magnitudes in there, you get 5 minus 2 times 10, which is what, 20? So it's minus 15 plus 1 half of c, which is 4. So you get 16 or something, right? But that's not how you add vectors, right? You have to find the x part, and you have to find the y part, and then you take the square root, right? By the Pythagorean theorem. All right, so the last thing I want to say is find the angle. So this is sort of a common convention, right? So we have to find an angle, but the angle I always use is, I'll write it down here. So I'm going to always measure counterclockwise from the positive. It's usually, this is the typical sort of convention, but just to be 100% clear. So I want to find the angle if you start at the positive x-axis and go counterclockwise till you get to vector r, right? And that's what I'm trying to find. All right, so how do you do this? So the first thing you do is you need to sketch the vector. You got to use an inverse tangent, right? Because I told you this before. But to use the inverse tangent correctly, you have to sketch the vector and see what quadrant it's in, basically. So let's figure out how you do that. All right, so the coordinate axis is a little bit messed up, but it doesn't matter. All right, so this is your y-x axis. All right, so the x part is negative and the y part is negative, right? So what quadrant are we in if they're both negative? Third, right? So what you do is you just sort of sketch it out. So I know it's going to be in the third quadrant, so I'm going to draw the vector in the third quadrant. Hold on. I'll use this. Okay. So the vector r is going to be somewhere in the third quadrant, right? So this is the vector that we just found. Because it had a negative x and a negative y part. We know it's in the third quadrant. So this, so it's negative, the y part's negative, but the length of that line is just how much ry is, right? Which is 20.78, right? So it's below the y-axis, x-axis, sorry. So it's negative, but the length of that line is just 20.78, right? And the length of rx, right, is 17.00. So it's in the negative x direction because it's the left of the y-axis, but the length of it is just 17, right? So then what you can do is you can find this angle all the time, which is what is known as the interior angle, the angle inside that vector, right, inside the triangle. So how would you find that angle, theta? Well, it's the inverse tangent, right, because you know the opposite side, which is 20.78, you know the adjacent side, which is 17, right? So you take the inverse tangent, basically the absolute value of both of them, which is, sorry, the opposite is 20.78, and the adjacent is 17.00. So what we say is the interior angle can easily be found, and that works out to be 50.72. But that's not the answer that I'm looking for, because if you look at the question, I want the angle measured counterclockwise from the positive x-axis, right? That is not 50.72. This is the angle from the positive x-axis. So let me just sketch this quick. All right, so it'd be this angle here, phi, right? That's the angle from the positive x-axis, right? So how would you get phi? I mean, it's pretty straightforward if you sketch it out. You add 180 degrees to this angle, right? Because it's 180 degrees to get the negative x-axis, then you add this angle, right? To get the angle from the positive x-axis, right? So the final answer would be phi is the thing we're looking for. It's 180 degrees plus 50.73, which is 230.37, right? So that's the angle from the positive x-axis, right? It's 230.73 degrees from the positive x-axis, right? So that's how you should always find the direction of these vectors, is to sketch the vector, right, to get it in the right quadrant, and then you find the interior angle, and then you can figure out whatever angle else I'm asking for, right? Does that make sense? So this is a general sort of procedure for any vector addition problem, right? You find the components, you do all this stuff. Yeah.
This will be on Canvas.
Yeah.
This is okay.
Mm-hmm.
How soon do you usually get these online? Both the video and the PDF after the lecture?
Half an hour to an hour after the lecture's done. Yeah. All right, so we still have a little bit more time. So I just want to start the next topic. We're not going to get that far. The homework assignment tonight will be something to do with this, right? Adding and subtracting vectors. But I just want to start the next topic, right? And we'll do an example and continue the next topic tomorrow.
What was this topic about? Like,
This is vector addition, vector components, vector addition, subtraction. Right? All right, so the next thing I want to talk about, like I said, we'll do an example tomorrow, but for now, I just want to start it. So there are other sort of things you can do with vectors that are sort of analogous to multiplication, but it's not really multiplication. It's a little bit different than multiplication. It's called what's known as the scalar product or the dot product. It's the same thing. You can sometimes it's referred to as a scalar product. Other times it's referred to as the dot product. So the reason why it's called the dot product is because the symbol to perform this operation is given by a dot between two vectors, right? So how do you perform a dot product? It's pretty straightforward. It's actually really easy. You have two vectors and you're trying to find the dot product between them. All you do is just take the magnitude of vector A, multiply it times by the magnitude of vector B, and multiply by the cosine of theta. Theta is the angle between the two vectors, right? So you have two vectors. The only basic thing you have to do is find the angle between them, and then just multiply the cosine of that angle by the product of their magnitudes, and that gives you what's known as the vector dot product. So the vector dot product is also known as a scalar product because what you're doing is you're taking two vectors, right, which have a magnitude and a direction, these two arrows, and what you get is just a number, right? So this doesn't have any direction associated with it. It's just a number, right? So it's a scalar. So you're taking two vectors, and the answer you get is just a number or a scalar. That's why it's also sometimes called a scalar product, right? But I refer to it always as a dot product. Now there are other ways you can do the dot product. Well, I should say, so what if the angle between the two vectors is 90 degrees? So you have a vector A and vector B, and the angle between them is 90, right? So what's the angle what's the cosine of 90 is what I'm trying to say? 0, right? So that means if you have two vectors that are perpendicular to one another, their dot product is 0, right? It's actually a useful way of figuring out whether vectors are perpendicular to one another. What you do is you take their dot product. If the dot product is 0, you know they're perpendicular, right? It's easy if they're just on the axes. If one's on the x and one's on the y-axis, yeah, it's easy. But you can have cases where that's not true, and the easiest way to do it is if the dot product is 0, then the angle between them is 90. Now that leads us to another way to write the dot product, which we'll get to in a minute. But the basic idea is that the dot product can be positive or negative depending on the angle between the vectors, right? So if the angle is between 0 and 90, the cosine of an angle between 0 and 90 is a positive number, right? So you get a positive answer for the dot product if the angle is between 0 and 90. But if it's between 90 and 180, the cosine of an angle between 90 and 180 is a negative number, right? So you get a negative answer for the dot product. So the dot product can be positive, it can be negative, it can be 0, right? And if the angle is 0, then it's just the magnitude of their, it's just the product of their magnitudes, right? Because the cosine of 0 is just 1, right? Okay, so what we can do is you can use these unit vector things to state something about the unit vectors, right? So remember, unit vector is a little bit weird. They just basically mean in the x direction and the y direction, but specifically, if you remember when I went over it, the x unit vector is a vector that's 1 unit long in the x direction, right? And the y unit vector is 1 unit long in the y direction, right? So if you take the dot product of x with itself or y with itself, you get 1 times 1 because the magnitudes of each thing is 1. And it's the same vector, right? So they're pointing in the same direction. They're both pointing in the positive x or positive y direction. So the cosine is 0. So basically, if you take the x unit vector and dot it with itself, the dot product of the two x vectors or two unit y vectors, you get 1, right? But if you take x and you dot it with y, or y dotted with x, the angle between x and y is 90, right? So you get 0, right? So the dot product of the x unit vector and the y vector is 0, but the dot product of them dotted with each other is 1. So what you can do is you can use this to figure out another way to write the dot product. So if you write A in component form, it's ax x hat plus ay y hat. If you write B in component form, it's bx x hat plus by y hat. And if you're taking the dot product of these two things, so there's a dot between them, what you're doing is you're taking ax and you're multiplying it by bx, and then you're taking in the dot product of x and x. And then you do, it's sort of like the commutative law, basically. Then it's ax x hat times by, and then x dot y, right? It's x and y here. And then you do this term here, ay. So it's ay y hat dot bx x hat, which is this term here, and then ay by y dot y, which is this term here. So you see the x dot y hat things become 0, and these become 1. And this is the other way you can write the dot product using the components, right? So it's ax bx times ay by. So there are two ways to write the dot product here, right? A dot b is equal to ax bx plus ay by, or a times b times the cosine in between. So depending on what you're given, sometimes you're given the vectors in component form, right? You know the x and y parts of both the vectors. So in that case, you would use the left-hand side of this equation. Sometimes you're given the magnitudes and the angles of the vectors. And if you're given the magnitudes and the angles, you use that equation, right? The other way to use this equation is to find the angle between two vectors in general. If you know the x parts and the y parts of these vectors, you can find the magnitude. So suppose you're given two vectors, right? And you know the x and y parts of two vectors, right? You know ax and ay, and you know ay and by, right? How would you find the magnitude of a? So you know AX, you know AY, you know BY, you know BX, right? So how would you find A, the magnitude of A? Right, it's AX squared plus AY squared square root, right? So you know A. How would you find B? BX squared plus BY squared square root, right? So then what you could do is you could find the angle between the two vectors easily, right? Using this equation too, right? That's another way to use this equation. All right, so one last thing I'm going to say, and then we'll do some more of this on, I'm trying to think if I want to do this now or later. Yeah, there's just a few more things. So the other way to define this dot product is also known as what's kind of a projection operator. So why is it called a projection operator, right? So suppose you have these two vectors, A and B, right? And you take the dot product of them. So what you can do is you can break B up into two parts. You can take, say, there's a certain amount of B that's parallel to A, right? Whatever direction that is. And a certain part of B that's perpendicular to the direction of A, right? Or perpendicular to A. Because you can write vectors like this. So basically, as long as the components of the vectors are perpendicular to one another, you can write the vector down, right? So basically, what I'm saying here is that you have this generic vector A, and then there's a part of B which goes in the same direction as A, which is B parallel, which is this thing here, B with two parallel lines. So that's this part here, from here to here. Then this part here is perpendicular to B. And when you add these two components up, you find the vector B. It's another way to write vector B. So B perpendicular is this thing here. The upside down T means perpendicular. All right, so what happens if you take the dot product of these two things? Well, first of all, you can write B in a sort of weird way, which I'll explain right now. I just lost the clock. All right, so I got a few more minutes. Like, let me just do 2 or 3 more minutes. So you can write B like this. You can say it's a certain amount, B parallel, or a certain amount that's parallel to B, to A, I should say, is B parallel. And this thing is a unit vector that's in the same direction as A, basically. It points in a direction parallel to A. So it's a vector that's 1 unit long that points in the direction of A, right? That's what this thing is. And then plus B perpendicular, the amount that's perpendicular to A. And this thing here is the unit vector that points in a direction perpendicular to A, right? So this is another way of writing the vector. It's a weird way of writing it, but this is another way to write it. And A is just A all in that vector, right? It's parallel to A, right? Everyone understand sort of what I'm saying? So if you take the dot product of A and B, all you're doing is, if you use this definition here, you're just multiplying the components together, right? You multiply the parallel components together and you add it to the perpendicular components. So when you do that, you just get this, B parallel times A, because there's nothing here for the perpendicular part. So what you can easily do is find how much of B is parallel to A using the dot product. It's just A dot B divided by the magnitude of A. Basically, that's why it's called a projection operator. You're basically finding how much of B points in the direction of A using the dot product. That's why it's called the projection operator. The last thing I want to say, and then we're going to do examples with dot product. The first thing we're going to do tomorrow is an example of dot product. Is an easy way to find the magnitude of a vector is to take the dot product of itself with itself. So if you want to find the magnitude of vector A, if you take A dot A, you take A and you dot it with itself, it's AA, the magnitude of A times the magnitude of A, because it's the same vector, times the cosine of the angle between A and A. What's the cosine of the angle between the same vector? 0, right? The cosine of 0 is just 1. So you get A squared, right? So if you're trying to find A, you take the square root of both sides, and you get the square root of A dot A is the magnitude of it, right? It's another way to find the magnitude using the dot product. But like I said, so on tomorrow, what we're going to do is an example with a dot product, right? And see how it works. But tonight, I'm gonna post an example of, homework will be adding vectors, right?
The homework we're running at
Yeah, I'm gonna post it sometime today, but it'll be on Canvas, yep.